right? So I've been able to record since yesterday. This week kind of moving smoothly. All right, so we have started recording, right? So let us move through quickly with our presentation so that persons can get some rest and continue your work and continue to study. All right. I know that a lot of persons say they don't have to study because it's online and they have opened the test capability and all of that. But you still need to study. You still need to do your reading to be able to be as successful as can be. All right. All right. Our overview, we'll be looking at introduction, HVAC system selection, the basic components of an HVAC system, how HVAC systems work, classification of HVAC systems, types of HVAC systems, HVAC control systems, benefits of using controls, right, and review of lesson. All right. So we'll be this lesson is really looking at HVAC systems and how it impacts our facilities and our livelihood, right, and our comfort level. All right. HVAC systems are milestones of building mechanical system that provide thermal comfort for occupants accompanied with indoor air quality, right? What do you mean by the milestone, right? This is really a accumulation of years of research and years of practice, right, in persons actually desiring comfort, right, as it relates to indoor standards, right? Comfort in terms of being cool at all times, right? Being able to do your work with ease, right? All of this will impact our daily activities and productivity, especially in this time when we're talking about working from home, right? I know that a lot of persons might or might not, and some might not have AC or HVAC systems, right? So persons that do have will find a little bit more ease in working from home and studying from home, right? Again, the word HVAC stands for heating, ventilation, and air condition. So it encompasses all the building, air quality control, the heating of the building, how well ventilated it is, and how cool it is, right? So that's basically what a HVAC system entails. Now, HVAC systems are effectively everything from your air conditioner at home, right, to the large systems used in industrial complexes and apartment blocks, right? So we're saying that from what used, not even your home, as small as what is being used in your car, is considered a HVAC system to large units that are used for mass cooling, such as refrigerated rooms, and so forth, right? So all that HVAC systems will encompass all of these systems, right? HVAC system aims to provide thermal control and indoor comfort. Thermal control meaning the temperature of the air, right, or the temperature of the environment in an enclosed space, right? Such as your room, such as your office, right? Such as your factory, right? Or shop floor. This is what HVAC system seeks to control the comfort of your indoor environment, and one that is designed using the principles of thermodynamics, fluid mechanics, and heat transfer. So all of these are actually incorporated in our HVAC system for efficiency purposes, right? So as research varies over the years, we realize that our HVAC systems become more and more efficient, such as your inverter type air conditioned units, right, and so forth. So as we go along, due to the connectivity and the smart devices that are coming out now, we realize that we have more control over our environment when it relates to temperature, right? They are more efficient. Like for instance, a couple years ago, I talked to this lady. She was having some problems. Well, she was experiencing some problem with her light bill, like most of us have, right? And I was saying to her, I was actually doing just a quick energy audit by just talking to her, right? I asked her if she change out her light bulbs. She said yes, right? Which we're going to look at lighting and illumination further along. I asked her about if she use a gas stove or electric stove. She said gas. I asked her if she have AC. She said no. I asked her about her fridge. Yes, she have a fridge. The age of the fridge, right? It was actually more than 10 years old, right? When you look at the age of the fridge and the efficiency of the fridge, then it actually is low, right? So the fridge itself is an HVAC system, you know, so its efficiency is low, right? I tell her, she said, yeah, man, it's still working and thing. I was trying to tell her that she need to get rid of the fridge and buy a new type fridge that uses a better, a more efficient compressor, more efficient electrical control, more efficient temperature control, right, and better cooling. Well, eventually, um, she listened, right, because the bill was getting out of hand, right, and as soon as she buy the fridge, right, and she, I think she sell or give away the previous fridge, I don't know. I'm not certain, but what happened was that her light bill dropped significantly lower than the previous months, right? And she came back and was saying it to me. I tell her, yeah, because listen, as technology improves, right, you realize that these things become more efficient, and the more efficient they become, right, is the better it is for you in terms of the electricity. Same thing with your car. You have an older model car, right? Persons might say a person with a newer model vehicle and say, boy, your engine bigger, you have a smaller engine. But what they don't realize is that because your model is older, past probably the warranty, then it's less efficient, right? And the newer car might be more fuel efficient because of the computerized system inside it and more burn the fuel more efficiently, right? Same thing with a older car, you probably say, but how much AC no cool? If in a newer car, you realize the AC is cool. What persons don't realize is that after a period of time, the system components become worn, right? You need to service the system as well, and these will contribute to the efficiency of the system, right? So same thing with the AC. After some period of use, we have to have our maintenance schedule, right? And you realize that after some months, or probably 3 months, you realize based on the use of the AC, it becomes less cool, right, in the room. And you realize once they come and service it, or they do the service in a unit, say whether central unit or split unit, then the AC becomes much cooler, right? So efficiency is a and when it's not running efficiently, guys, it will burn more energy. So if you have a unit that needs servicing and you don't service it, it will burn more energy because it takes more to cool the room. The filters are blocked, and then the AC start to struggle to clear to cool the facility. All right. All right, HVAC system selection. We said there are three main factors to consider to be considered when we are selecting air condition systems or HVAC systems. Now, one is a building configuration. What we mean by the building configuration? Whether the building is made of concrete, whether if it's made of sheetrock with insulation inside, and so on, whether it's made of board, right, on the outside. So the thermal factor of these materials will have a lot to do with the material itself. Also the size, right? Whether you have an open concept or it's a closed space, right? And so forth. All of this will actually affect the selection as it relates to the configuration of the room. Now, the climate condition now is whether it's in a hot area, like our tropical region, right? Or we're talking about a much colder regions in like parts of America, parts of Canada, when we talk about ice box, right? And that is why your fridge, if you notice your fridge at home, it have a winter setting, This is actually for areas that experiences winter to the extreme, right? When you are on winter setting for your fridge, what it does is actually shut down the fan in the fridge and well, it shut down the circle in the gas in the fridge and pull the cool from the atmospheric temperature around the fridge, right? So it pull from that to actually cool inside the fridge. All right, so we're talking about the climatic condition because the hotter the ambient temperature in terms of cooling is the more work that the unit will have to do, right? The owner's desire. No, this have a lot to do with almost every type of system we talk about, whether it be an electrical system, mechanical system, the lighting in the premises. A lot of it is going to be based on what the owner desires. Because if the owner needs split unit, right, then you have to provide him with split unit. If they want a central unit, you will size, you tell them the advantage and the disadvantage of having both systems, right? And choosing to make a proper selection. But ultimately, a lot of time it comes down to what the owner wants, right? So what the owner wants, they are the ones spending the money, they are the one financing the projects, and the HVAC system will be ultimately determined by them. You will provide the technical data and the know-how, and based on that, and the look of the system, the aesthetics of the system, then they'll make their selection. All right, and then you would now need um, to implement and install the system. All right, so we as engineers have a lot to play, right? A lot of time it's we don't actually select the aesthetics look. We just tell them the specs and then they'll select the aesthetics look, right? So that's basic. Give me a second. All right. All right. Some criteria can be considered as such as climate, the temperature, the humidity, the space and the pressure, the building capacity, spatial requirements, right? Costs, such as the capital cost, operating costs, and maintenance costs, right? Also, we'll do a life cycle analysis on the system and the system reliability and flexibility, right? So a lot of these will definitely determine if we get an AC system. A lot of time persons can actually afford to purchase an AC system, but when they look at the maintenance and operating costs, right, then they tend to back away from having an AC system, right? Sometimes you hear person say, boy, the AC in their home is a dinosaur, meaning it's not being used, right? It's just there because it was built with it. Probably they run it for the first month, and when they get the bill, them realize that boy, them can't finance it based on its operating cost, not even the maintenance cost, because the maintenance cost is not as strenuous as the operating cost, right? So these are things that we will mainly, the operating cost is what will mainly affect the purchasing or the utilization of our HVAC systems. All right. Um, all right. Some constraints to consider when we are selecting HVAC systems. We have to look on the available capacity, right, according to standards. So basically, there are a lot of software online software that they can use to determine the size of the unit that they need, the BTU, whether it's a 12 BTU unit, mean are 12,000 mean or 9,000 BTU or 18,000. You can either buy a 24 as well. So the capacity of the system will be that's one thing that you need to consider, and the constraints based on the space that you have, right? The building configuration again will be a constraint on the type of system, right? The construction budget, right? The money that you have to spend to to put in this system or to build the facility, right? How would it play an aspect in terms of the system that you would choose, right? The available utility source, right? Whether you have the supply voltage or not, right? If you are putting in a central unit, then you have to talk about in most cases, a three-phase, right? In some cases, it might be a single phase 220, right? So that again will determine the type of system and put a constraint on the type of system that you have, right? However, talk about the building load, the heating and cooling that the system will need to provide. This will actually put a constraint also on the selection of the system, right? So these are some basic components here, right? We talk about the outdoor mixed air and outdoor air quality control. We talk about the air filter, the supply fan, the exhaust or relief fans, and an air outlet, outdoor air intake, the ducts, if it, right? We have to talk about the terminal devices, the return air supply, the heating and cooling coils, very important. The self-contained heating or cooling unit, whether it's a self-contained or a split unit, the cooling tower being used. If there is a boiler involved, meaning if it have to provide heat. So like when we talk about countries like Canada and US, we have to talk about the heating part of the system. When we talk about locally, now we don't necessarily talk about the heating component because we already have a hot or a moderate climate, right? But in these countries, we do have to think about heating, right? Sometimes in a car, in early morning or when it's cold, you might think about heating, but then the car have to be at its operating temperature for you to be able to draw heat from the system, right? We talk about the water chiller, the humidification and dehumidification equipment. This part of it plays a very important role because if the humidifier is not working, then you're going to have problem when it relates to mold inside the facility and the air quality being poor, right? This is what they use to actually purify the air quality in the circulating air, because normally you'd have some amount of circulating here, and we use this part of the system will clean up the air so that it smells right to you. Now, this is really a layout. This is a typical layout, guys. It will change depending on the type of unit that we're talking about, right? So we're talking about, this is the flow. This will show you the flow of air through the system, the outside air. We're talking about the filter inside and the fan. We talk about the cooling coils that will bring the refrigerant from the reservoir, right, to or the compressor in some cases, to the cooling coils, to the coils to remove the heat from the facility, right? So that's basically, and if it has a boiler, then it will, the cooling coils will push the heat into the facility, right, via the fan. So this is just a basic illustration of a HVAC system, right? And remember, we said the HVAC is really the heating, ventilation, and AC, and that is why we have the boiler section in this case. Now, in your car, because most persons are familiar with the car system, what will happen is that you will pipe the hot water coming from the engine or from the radiator will pass through and goes through the body of the car and pass through the body of the car, so and then return to the car engine and then return to the radiator. Now, the heat that passes through the body, go to the body of the car is actually going to the coils inside under the dashboard. So under the dashboard would be your coils, and the hot water will pass through those coils. Now, if we are not supplying heat, then we are going to lock off the hot water from passing through the coils. If we want to supply heat, then what we're actually doing is actually turning on the flow or enabling the flow of hot water through the coils. all right, for us to be able to heat or warm inside the car. Now, so basically, this is your lowdown or your information on how the system work, right? First of all, the building automation device, such as your wall-mounted control or a computerized control, will be used to determine whether the heat or cool, whether to heat or cool the space. So we're talking about our climate control, right? So our climate control will send our signal to our main controller, right, to tell it if it needs to cool or warm the space based on our settings, right? The system then either heats or cool the coils inside, right? So it will determine based on your selection if we need to send heat or if we need to remove heat from the premises, right? Or from the space. When air brought in the form of outside is pushed through these coils, it is either heated or cooled before being pushed into the living space, right? At the same time, air will be displaced from the room back into the system, right? So as I tell you before, it's a circulating process where the air is circulated inside the space to eventually reach the desired temperature. So whatever the desired temperature is, that air will start to cool, right? That's how most of the time after set of persons, especially my kids when they come into the car. Listen, the car not going cool instantly, because we just come in on the car and turn on the AC, right? To cool it faster, we can remove the hot air inside by opening the windows and getting some environmental temperature here, meaning the air ambient temperature, and then it will cool faster. But if you're going there and keep it locked and want to cool it, it's going to take a time to remove the hot air from the system and replace it with cool air, right? So it will take a time. Now, what you do to actually speed up the process is actually in all systems is increase the speed of the fan, right? So no matter what the speed you put the fan at, eventually it will cool it. This is cool the space, right? However, depending on the size of the space now, you will want to for it to reach the desired temperature in the fastest possible time, right? And this is why you need to actually be able to control the speed of the fan, right? And this fan is actually the part of the system that will be pushing the cool air, right, inside the space that you want to cool. All right, so that's basically a very important aspect. So you don't really turn up the chill when you actually turn the fan. What you actually do is speed up the rate of displacement between the hot air and the cool air, right? So it's not the temperature you will speed up. All right. Smaller air condition units, so we have a look on the small units, may operate in the reverse, however, where they collect heat from within a space and push it out in order to cool a room down, right? We can see these kinds of system in places like cars, right? So we're talking about the smallest type of AC system available, right? You'll see them in places like cars, for example. I use a car because it's something that persons can relate to in terms of our HVAC system, meaning it have hot and cold, right, being provided. All right, this is really an overview of your small AC unit, right? We have a high pressure side and we have our low pressure side, right? And the expansion valve is what determine which side is our high pressure side and which side is our low pressure side, right? So the compressor here, we have our condenser here, right? We have our evaporator, expansion valve, we have our evaporator and so on, right? Our receiver dryer, this actually dries the air. You will find this inside the engine room of your car, right? So if you go inside the car, you'll find this in the engine room. The condenser would be where your radiator is, right? And you will have your evaporator, right? So your compressor going to be in your engine room again. Right, so in your engine room, your compressor is attached to your engine and it is turned via a valve, right? A belt. And when you engage your AC, meaning put power to your AC, it engage the gear inside the AC and start to pump the refrigerant around the system. All right, so here we have our evaporator. This is under your dashboard. So you will find this under your dashboard, and you will find your thermostat device under your dashboard as well. Now, what your thermostat device does is cause your compressor to turn on and off based on the temperature inside the car, right? So you realize that sometimes you hear your compressor chipping, or you feel when your compressor put load on the system, right? And you feel when your compressor cut out, right? The thermometer or the thermostat is what is causing that to happen, right? Cause that to happen. So this is basically how your car AC system or HVAC system will work, right? Um, so all that I just say, we have put it in word to describe the different parts of the system, right? We have the expansion valve, right? This device basically creates a restriction in the liquid line, right? Which in turn creates a pressure drop, right? So it actually is the part of the system. That is why the line is drawn here. That determines the type of pressure, whether inside the car you'll have a low pressure and outside in the system you'll have a high pressure build-up of high pressure to move the refrigerant around the system. Right, everybody can say why it have high pressure, because we have the output from, we have the compressor here, right, and the compressor is pumping along the system. All right. We have our evaporator, right? This device really removes heat from the space, right? So the refrigerant, for persons who don't know, is way below the freezing temperature. So what it does, because it will absorb the heat, and then that heat will go back to the compressor, and then it will be condenser will actually send that heat to the atmosphere, right? So it will remove the heat from the system. That's what it basically does, right? And thing. So when it removes the heat, what the fan does now is actually blow that cool air that has the heat has been removed from inside the car, right? To cool down the car. All right. Now the compressor. Think of this component here as basically the heart of the system, right? So it creates the energy or the pressure in the system to move the refrigerant around the system, right? Through the pipes and thing, through the expansion valve and so forth. Basically, that's what your compressor is. And that is why when your compressor in a car not working properly, then the AC person that they carry car to will tell you that they need to replace the compressor, right? So most of the time what is happening is that your compressor is losing pressure. So inside the compressor, some seal is not working, or some seal is gone and cannot be replaced, and hence you have to buy a new compressor, right, for you to be able to move the refrigerant around the system. The condenser, right? We said this device really pushes the heat that has built up inside the refrigerant into the outside air, right? So it actually evaporates the heat to the outside here. And this is actually found behind or in front, depending on which way you're looking at it from. If you're talking about from the front of the vehicle, it is actually before the radiator, right? If we're talking from the engine side of the vehicle, then it's after the radiator, right? So that little part that you see in the behind the radiator, between the front part of the vehicle and the radiator, that device that you see there is actually a condenser, right? So no, for persons who don't know, the refrigerant does not go to the radiator, right? It goes to the compressor, which is found in front of the radiator if you are talking looking from the outside, right? And right beside the condenser, a lot of time you'll have your dryer, right? And that actually is used to remove moisture from the system. All right. So we said basically here the dryer actually preserve the air quality, right? So it actually removes contaminants and moisture from the system, because the moisture is a contaminant that will damage the system, right? So without the dryer, the system will not cool properly, right? That is why if you have a system that was sitting for long, a car system, small AC unit system, and to say, guys, a window AC unit is a small AC unit, right? The ones that you see that they usually have in the windows, these are not the split unit, is considered to be a small AC unit. It's compact, everything is in the one unit, right? So if the refrigerant is contaminated, right, due to moisture and other contaminants, then the system will not cool efficiently because it's not able to remove the heat from the space that they want to cool efficiently. All right. The classification of air conditions. We said that air conditions or HVAC systems are classified in two type of system. We have the central system and we have the decentralized or local system, right? So we're going to look at this a little bit further, what they are, right? So this is the central HVAC system. So this is really a flow chart to explain what is happening with the different types of unit, right? So for the central HVAC system here, we have our all air system type, we have our air water system type, we have our all water system type, we have water source heat pumps, and we have heating and cooling panels, right? I will further break down the all air system into these categories: single zone, multi-layer zone, terminal reheat, dual duct, right, and variable air volume, VAV, right? And we can break down the air water system into fan coil units, induction units, and fan coil units, right? What does this actually mean in actuality, right? The central HVAC system may actually serve one or more thermal zones, right? That is basically our central unit. When we see the big unit outside of the building, so they are normally located in a when we talk about high-rise buildings, some of the time they'll be located on the top of the building. For buildings that are more of a spread horizontally than vertically, then you'll find it outside to one area, right, and serve many zones. So you might have a central unit serving 3, 4, 5 zone, depending on the size of the unit itself, right? The volume of air that it's able to cool, right? Central systems must condition zones with their equivalent thermal load, meaning if you put too much room or spaces on a central unit, meaning if it's undersized, what will happen is that it will not cool the spaces properly, and you will have a lot of mold buildup because the air quality, the air will not be dry enough, right, to actually so what will happen is that you'll have a lot of moisture in the atmosphere, and we know that when we talk about ducts, these are dark spaces that mold will start to build up, right, and then it will cause the building to be contaminated. So you might have persons that have asthma, them asthma starts flare up, persons with allergies, them allergies start to flare up, and these things. So it's always good to actually size. Now, typically when you are installing a new system, it's normally sized properly. The problem is that when we start to make additions and we did not account for it, right, and start, we don't want to buy a bigger unit, we don't want to buy another unit, and we don't want to buy a split unit. So what persons do is actually modify their ducting, right, or modify the duct and start to take from the AC, the central unit to a new location, So what this does is actually add more, because every new space you add to it, you can consider it as adding load to the system. Similar to that when we talk about current, right? When we start to add more load, we start to pull more current from the system. And if the system is not designed for a particular current, then what will happen is that the system will start to trip, or the cables start to burn, right? Over a period of time, it break down. All right. Now, for these type of system, what this mean by call control points is that in each space that is served from the central AC, it will have a local thermostat control, right? That is able to control the cooling inside that space, right? So if we have 4 spaces, then we're going to have 4 individual control points that are able to control the air that is coming to that particular space. All right. So this is our local HVAC system. So this is a flow diagram showing your local HVAC system, right? We have our local heating system, we have our local cooling system, local ventilation system, local air conditioning system, and the split systems, right? And we can further break down the local air conditioning system into window, air conditioner, unitary air conditioner, and package rooftop air conditioner, right? So what do these actually mean, right? So we talk about as it relates to the local air conditioners, right? Some buildings can have multiple zones, right? Or have a large single zone which needs a central HVAC system to serve and to provide thermal needs, right? However, other buildings may have a single zone which needs equipment located inside that zone, right, by itself, such as a small house or a residential apartment, right? So that is basically drawing an analogy between the central unit and our local unit, right? So we're talking about the local being much utilized in individual spaces in a smaller capacity. But however, nowadays, what persons are doing, rather than buying a big central unit, they're actually attaching small split units to different offices. So for instance, you might have a 2-story building, or even a 3-story building, or a single-story building. But what rather than have a central unit, what persons tend to start to do to have a better control over their zone, because I mean, like for instance, by the electrical office where you have a number of persons sitting in the space. Some persons might want the temperature locally there to be, say, cooler than some persons. Then what you have to do is actually carry your sweater, because you can't go turn it down, because then the one will tell you say him hot and uncomfortable, right? And it's easier to wear a sweater than actually for him now. He may have to probably put a local fan on his decks or her decks, right, to cool locally. But so it's better to wear a sweater. So that's basically the reason why persons tend now to start to make offices separate and give them no. Most of the time, what they do is actually have a comfort level for the manager or the director. So they put all of the general staff in a one area. You have a suffer in the cold space, and the manager office probably have an independent split unit, right? So he has more control over his split unit or his cooling and his comfort compared to you that is sitting in an area with more than one person's there, right? So they have more control.
And there are times, so why then do it like that? For example, a building that has only a central unit. A person might decide to come to work on a weekend when most persons are not in the building, right?
Mhm.
I don't want it could be 1 or 2 persons, or 3 in different office spaces. And
Yeah.
if you have a central unit that is dealing with that whole entire building, for them to, I mean, keep cool because it is an enclosed building.
Mm-hmm.
So for them to turn on the central unit to cool the whole entire building for just one office space, or 3 office space comparing to the number of office spaces for that building. That is just a waste of energy. So what they
True.
will do is to use the mini split unit for each one of those offices, or they use both the system, the central unit and the mini split unit. So in the event if a person decides to come to work on a weekend to work, they don't have to resort to turn on the central unit. The split unit for that office, you could just turn it on and
And
just
fully
work
fledged.
alongside rather than turn on the whole system that own a waste of energy.
Yeah, that's true. And what you realize that more and more in today's environment, we are using more of more split units than central units because of this main fact that um, how the work of the spaces that work are divided now, right? They realize that the central unit, right, becomes ineffective. Like a space, however, like a supermarket, then the central unit is best, right? So that's why again we say that the configuration of the space is a major aspect nowadays when we're talking about the selection of HVAC systems, right? Um, so here are the HVAC system requirements, right? The primary equipment, we have this space requirements, we have the air distribution requirements, and we have the piping. Now, under the primary equipment, we have equipment such as heating, cooling, and the air delivery system, right? Under the space requirement, we have to consider the equipment room where we're going to put the equipment, the HVAC facility, the fan rooms, right, the vertical shaft, the equipment access, how we're going to access it. And when we talk about distribution, we have to talk about where to place the outputs, right, and where to run the duct, right. And the piping is really what will deliver the cool air throughout the system, right. Um, so basically, we're going to look at the different types of HVAC operation, right? This is the heat pump type, right? So this is a type of, actually the most basic type of AC system, right? We have our compressor here, right? We have our evaporator. We have the liquid flow. We have the expansion valve, which is basically a check valve type of thing, right? And we have our condenser here. All right, so this is basically the main components of this type of system, right? And we have shown here the flow of liquid throughout the system, right? So the liquid will flow in the direction of shown by the arrow, right? And this is actually shown in red because we are saying that here, after removing the heat from the system, it is in this part of the system, the condenser, where it is given off to the atmosphere. All right. Now, put all of that in context. Heat pumps, right, are basically efficient type of system that extract heat from cold spaces, right, such as outdoors during winter, and then warms and release it into a room, right? So we're talking about like in America where we're talking about like or cold climate and they tell us, listen, go turn on the heater, right? And then when you turn on the heater, then you tend to find warm air, right? Because there will always be a transfer of heat, right, between two liquid that is of different temperature. Similar to when you have, for persons, you might have a bottle. For instance, when my kids were small and they make their bottles and the bottles too hot, right? What we tend to do is what? Put the bottle, get a cup, fill a cup with some water, and put the bottle in there for us to remove the heat from the bottle, and then it will move to the water that is of the regular pipe water, right? So this type of system will do the same thing. It will remove the heat from the atmosphere because you do have heat, because we're gonna have sun. It's just that the temperature cold, right? And then it actually put it inside this enclosed space to warm the space, right? So this is basically our simplest form of heating system. All right. Here we have our rooftop unit, right? You will see this a lot in movies and shows for persons who have been on some buildings out here, tall buildings, right? You will actually find your central unit on top of the building. This is basically how the unit is, where you have the enclosure and thing. You have the air supply duct, right? The supply air fan and so forth, which is spun by the motor. So we have our motor here, right, and supplying, right? We have our return air dampers. We have our, right, and we have our return air duct inside here. So basically, this is where the air will return from the space, right? So it's cooling the spaces underneath. So this is our return duct, right? And this is our supply. Good. So this is basically our typical configuration. If it is more complex than this, this is just an overview of what is taking place, right? If we were to actually go into much detail, we'll probably teach one unit for the entire term, right? If we really want to do a course in HVAC, right? To do a course, actually an HVAC course can run you up to roughly a year of studying or 2 years of studying based on the depth that you want to go into that course, right? So what we're doing is really just doing an overview of the system. All right, so we give you some documentation on rooftop type. These are also known as air handlers, and as their name suggests, they are large HVAC system that is placed on a rooftop in order to moderate the temperature of a large space. So, for instance, such as a warehouse, a supermarket, right? Rather than to have the unit outside and take up more space, what they'll do is put it on a roof. Wait a second. Yes, they'll put it on a roof. Give me a second here. So they'll put it on the roof, all right, where you already have space. Now, if we're talking about mounting these rooftop units, then we're talking about concrete or slab roofs, right? It won't be possible to put it on a zinc roof because of the size and the weight of these units, all right? It's better to put it on a roof that is of slab configuration or material. Now, here we have our water source heat pump, right? This type here. And it's really a breakdown or a block diagram of what is actually happening, right? In terms of the basic function, we have our aquifer here, right? And this will show you our flow, right? So here we are seeing our flow. And we actually have this flow in our reservoir or aquifer. We have a flow this way. We have our irrigation pumps that is pumping to our heat pumps. So what is actually happening? We are actually removing heat and from one source and really sending it to another source, right? So this actually source will be a return flow ducts, right? So for this type of system, this is not utilized much out here or utilized much overseas, right? Because of how the system and the reservoir that is required to do this type of system. All right. So it's really a geothermal process, guys. And as I say, it's not really used internationally, right? It's an uncommon type of process. In times gone by, you might find more use of it when we have geothermal energy available. But because of these split units and the advancing heating and ventilation systems, AC systems, then we move away from these type of technology. But I still have to show it to you because it's still being utilized in some places, right? We have our packaged unit. So this is basically our window type unit, right? Where everything is actually packaged in one um, device, right? So we have our capacitor for starting purposes. We have our blower, we have our circuitry, we have our compressor here, and we have our condenser coil, right? This was once utilized a lot, right? But as time goes on and technology increases, then we start to talk about split units, right? So we tend to move away from, but over UA, guys, I should say that over UA, these compact units are really used for when they're having their mass exam before this whole COVID thing, and they have the exam room where they put up the tents, right? What they'll do is carry these portable cooling units. They have them as portable cooling units, and they'll mount them, install them, and they'll cool the space while the persons are doing exams, right? But again, they don't have any use for them now because we talk about online exams. So the COVID has changed or make them redundant during this time, right? Um, so that is really what your compact unit looks like. There are two types of package air conditioner, which I tell you about. You have a window unit type, and we have our portable unit type. Some persons might use them as fixed unit types, right? But depending on your use, the configuration of the system will remain the same, right? So the system will remain the same. It's just that your usage, right? And the usage will determine the type of package that you, whether it's a larger package or a smaller package that you're utilizing, right? Now, in terms of its operation, package air conditioners with air-cooled condensers, right? Are cooled by atmospheric air and are there for outdoor units, right? So these are the types that they'll use in like the tent and so forth. These devices have a fan that sucks in air before blowing it onto the condenser. So for persons who don't know how window unit look or how it works, and they are simpler to actually repair than the split units, guys, right? These window units were easier to repair than because of the technology involved. It does not utilize a whole heap of electronics compared to that of the split units, and for instance even the newer inverter types, right? I have
They're easier to install too.
repeat.
They're easier to install too.
And easier to install as well, because all you need to do is just even if the window is larger, then what persons will do is tend to frame out the space and install the window unit, right? Easier to install, easier to supply, easier to do everything, right? But again, they are finding less and less use because of the newer split unit. Now, with the split unit, however, most of the time when the board gone in the split unit, it's very difficult because we have so many different brands now, and we don't have parts for a lot of the brands. Then you have to actually throw away the split unit. So you might see somebody and you say, boy, well, you just have the AC throw them like that, right? When you take a stop, the AC just not powering up, right? And then can't get the board, right? Or something like that. So these had their advantage in terms of repair and parts, right? But however, if they are not maintained properly, because they are sucking the air directly and pushing it into the space over the cooling coils and things, then these have to be maintained on a much regular basis, meaning you have to take out the filter, clean it. Sometimes you have to wash down the outside part of the unit, the part that is showing outside, right? And that is why a lot of times these units tend to not cool and break down because of lack of servicing, right? So we show it here, right? A more this is our split unit here. We have our outdoor unit. So this is what we are utilizing a lot now, right? So we're utilizing this a lot, guys. This is our new technology. I will push it even further to have our inverter type ACs, right? Can anybody tell me what the inverter type AC mean? Because persons use the word, but they don't understand what inverter type AC mean. Anybody have any idea what it mean? Yeah, just quickly share with us if you understand what the inverter AC is. Anybody?
Um, what I do understand from the inverter type AC, they are more efficient than the regular type of AC, which most businesses and government building, they are changing out the regular type using the inverter type because they are energy efficient. Um, they are able to use both. They can provide heating and cooling. Um, Depends on what you want them for. So that same AC, for the most part, we don't need to use the heating aspect of it. We use the cooling aspect of it. But
Okay.
if you were in a country like America that at times experience snow or or summer, it can be used for cooling purpose and both heating purposes.
All right. All right. And just to add to that too, is to say that with the inverter type compared to that of the normal type, or all the normal type ACs work before, right? Or even now, the normal type, if you were to get a normal type, which is very difficult now, is that your compressor will run constantly, right? What will happen is that when you are at the desired temperature, it will stop the compressor, and then when it goes to the lower temperature, it will start the compressor, right? So it is a starting and stopping similar to what your fridge is doing. Everybody understand clear? Now, with your inverter type unit now, because of the level of control inside the inverter type unit, what will happen is that it will start now to control the compressor, the speed of the compressor, right? How fast, how much work is put into the compressor, right? And how much work is going out. So the power in and the power out of it, it will manipulate that for the compressor. Now, that to say that if you have less persons in the room, right? So we set the AC at a particular temperature, right? What will happen is that when you have more persons occupying a space, the ambient temperature going to go up based on the number of occupants, right? So everybody going to give off body heat and it going to contribute, and then the AC after it. So what will happen now with the inverter type AC going to speed up, right? And start to cool the place faster. Now, when people come out of the place now, what will happen with the regular type AC, it will cut off the compressor, and the compressor will stop, and then the place will drop down to whatever temperature it will drop, and then it will chip in again, and then it will have the starting current, and then it will build up back to the temperature where it then cut out again, right? But with the inverter type, when persons, the occupancy get less and the ambient temperature inside the room drop, because of the control and the sensitivity of the device, the compressor will slow down now, right? So it will slow down and hold it at the set temperature. So it's not dropping down where it will shut out the compressor, right? But it will slow down the compressor, the work done by the compressor, hence consuming less energy than when you have the compressor running for a long period of time and then stop and then run it up back and then stop and then run it up back, right? So we know we are controlling the output of the compressor compared to that of the input, right? And we are able to control the temperature and the efficiency then of the inverter type unit, right? So that's basically why we utilize it a lot more, because of the power consumption. It will consume less power because it don't run constantly like the normal unit, meaning at one speed all the time, right? So that's basically it.
Yeah, is that so really make it be energy efficient enough? Because
Hmm?
in the, as you explained, is that
Yes.
really what makes it energy efficient? because for the normal type, as you have just said a while ago, the compressor would stop run after it reach a certain temperature, cooling temperature. And then for when the temperature begin to drop by virtue of a number of persons in the room or persons or frequently person who open the door to cause hot air to come in, then after it begins to come in, that starting current is always 6 times or more than the running current. So that
Yeah.
now cause you to burn a lot of energy by
And
virtue of
actually,
having the
when you talk
starting
to
current.
persons, when you talk to person who's afraid or not to, it actually takes more to cool a space when the temperature drop that low than actually trickling down, or I should say
Yeah,
trickling down, right? It
yeah,
will take more, as I say, each time the compressor going to start to cool the space, right?
yeah, because
So,
go ahead.
yeah. So what the inverter type does is actually control the frequency. They use frequency control,
Yeah,
right? So the voltage will remain the same. What they do manipulate is the frequency of the supply that is being supplied to the compressor. So by manipulating the frequency, similar to what VFD, frequency variable frequency drive, they are
yeah,
able to control the speed of the compressor, right? So you have a continuous feedback loop
yeah.
then,
Because
right?
there's no time with the inverter type where the compressor is shut down altogether and to start up back, as you'd have run into having the starting current issue. So it keeps it going, but
Yeah,
not, more energy efficient in the sense
yeah,
that um, it cut down the speed whenever the room or the space reach that desired temperature, cut it
yeah.
down instead of shut up the computer, the compressor altogether.
And it
If it
actually,
was doing, go ahead.
yeah, continue. No, I
Yes, I'm
was
saying
saying,
if it was doing that as the regular type, then would have been at square one where we have to be starting the compressor when it shuts down, and then we'd have no the regular
yeah,
starting current, which is always 6 times or more
yep,
than the
and
running
it
current.
actually run to the temperature. So it actually save a lot, you know, if you compare the energy consumption of a um, inverter type to a normal type, a whole heap of energy you save.
Yeah, Wolper energy
Whole
save.
heap of energy.
But that's the reason why they are more expensive, the inverter type than the,
Yeah.
well, you can't get the regular type because those are fade out. Those are old technology.
Yeah, yeah. So technology do changes, and we have to keep abreast as engineers, right? And I know nothing new, you know, guys. As we tell you, a frequency control it do, right? This is something where you learn in a power electronics. If you do power electronics, these are something where you learn in your control systems. So all they are doing is just incorporating all of these technology because of micro electronics. We're able to manufacture these devices on a smaller scale so we can put them in other devices, right? So if we are able to minimize the whole aspect of frequency control, then we can actually fit it into another equipment such as the inverter type AC, the inverter type fridge, and all of these things, right? To boost the technology, right? And to boost what is available to persons, right? So this is where our engineering knowledge come into play, our engineering ingenuity come into play, and how we actually contribute to problem solving in the environment, right? Um, all right, so most persons would be familiar with the central unit. Again, as I say, you have the outdoor unit, which houses your compressor, your fan, right, and so forth. And you have your inside unit, which will have your evaporator and a blower, right? So you have two fans in this type of unit. You have your condenser fan and you have your blower inside the building, right? Now, when you're servicing your AC, most of the time what you'll see them do is service the indoor part of the unit by cleaning the filters and so forth, right? And cleaning contaminants from the inside part, which is our evaporator unit, right? So this will actually enhance the efficiency of the unit and cool the space much better. All right. This is just telling you what the term split mean, right? You have the mini split type, also called the ductless system, right? And you have this the central system. In these units, this is basically what I'm talking about, right? This is basically your ductless system. Now, these are actually pipes that are also insulated. So what they'll do is run copper pipes from your evaporator units to your condenser unit outdoor, right? And then it will actually be insulated so as not to lose any efficiency, right? So if the insulation is gone, what it actually does is actually contribute in a negative way to the efficiency of the unit, right? Here, they're actually using in a diagram showing you it controlling two evaporators. So hence this is a larger type of compressor outdoor, right? Now the compressors can either be mounted on base, so they can either put up a base, right? Or similar to a transformer mount, right? A pod mount, or you can actually mount it on the wall, but with the use of brackets. Now, one time you have to go and build these brackets. You can actually, when you buy a new unit, you can buy the brackets as well for mounting. Right, so you don't need to go anywhere else and get in a bracket. You just buy the AC and you will get and you can buy the mounted brackets. Right. The smallest of all the system, this is basically our split unit. And I would not say smallest, we're talking about modern systems, right? Where the systems kind of become more. So one time when you look at a 9,000 BTU unit, and now when you look at an inverter type BTU unit, same 9,000, the physical appearance is going to be smaller, right? So it because the system become more efficient to that of your older type systems, right? They require minimal wall spaces because most of the time they are mounted indoor in spaces where you don't really utilize, right? The compressor and heat exchanger unit can be located further away from the main building, allowing greater flexibility in use, right? Meaning all they need to do is just pipe it to the compressor unit. All right, so you might have your evaporator unit in one location or one side of the house. It does not mean necessarily that you're going to have the compressor unit directly behind that wall. It can be on another wall, right, where they pipe to it. Now, what you tend to realize when you buy a new split unit, right, persons don't realize it, that it is so designed that wherever you want to run the pipe, you are going to have the space provided. They take all of that in consideration. It can be directly the wall, it can be to the left, it can be to the right, right? So they'll take in consideration that you might mount it directly behind the wall that the evaporator is mounted on. You're going to take it as if you want to mount it to the left or to the right, right? So it there's provided knockouts in the unit for that, right? So you don't have to cut out anything, you don't have to cut out the side of the unit. It's already there. All you need to do is knock it out and then you install the unit, right? Now, with the ductless type of air conditioner, you will find on the market a lot, and that is the inverter type, right? As it's explicitly designed for home use, but it also finds use when we talk about commercial and industrial settings because of its versatility and the configuration of the building. So persons are moving away from central units, and when you look at a building, there's so much compressor the outside of the building. Probably that'll take up one wall round at the back of the building, right? What we realize is that persons are moving away from the central unit because of the inefficiencies of cooling running the entire unit, as Mr. Freighter says, to actually cool a small space, right? It's not that the central unit couldn't use it because you can send duct to different location. But when you turn it on, all you do is turn off the duct, so you don't have any airflow into the space. The unit is still running at full capacity, right? So that makes the unit now inefficient, all right? All right, HVAC controls, right? This, without going to go into any detail, as we tell you before, we can't do that in detail because if we look at these
Sir,
things in detail, yes.
sir, with the system,
Mhm.
so they got one that use inverter, the duct system.
No, man, the ductless system, we have to talk about the duct system, the central unit.
Central unit, yeah.
Well, I have not researched it before because, as I tell you, persons, even know when a person's central unit stop work, they tend to stop by split unit, right? I would have, that
Okay.
is something that I can't speak to
No,
directly now. I would
no,
have to
because
research it.
based on what you explained about the inverter. So
Yeah.
if you close the vent them, say you occupying a small area, and
Mhm.
you should close the duct in the rest of the area, it's supposed to slow down the motor, so it's supposed to
Yeah.
burn
No, but
as
look at
much.
it, it's still all right. Remember, so when you install a central unit, look at it at this way. It's still going to be very inefficient because the size of the duct, we're talking about ducts that are probably 2 foot by 2 foot, right? So that's
Okay.
basically 24 by 24 or 30 by 30. Now, I have a building similar to if we were at UTEC now, I would point it to the um, well, we have some central units at the back of the engineering building. Now, remember, when me up on the second floor and the unit on the ground floor, I mean
Yeah.
lock off my vent on the second floor, we still have that capacity adducting from the machine, the central unit to the
Oh,
duct.
so full them area there. Okay.
So it's still going to be inefficient compared to
Sure.
that of the split unit.
Okay. Okay.
Because the air blow through it, it's not like the ductless unit or the split unit where I just refrigerant run through the piping, right? Here
Okay.
you actually blow through the duct. Here, yeah. So
Ah.
that's why them tend to start move from them, right? So when you see a building will start a problem with them central unit, most of the time they either buy a new central unit if them can afford it, or they want to
But
go that way, or they just start to put split
sir,
units.
in terms
Yeah,
of the cost,
yeah.
one central unit can do like say you have a 3-floor or 3-story building. One central unit compared to about like 10 split unit.
Well, but it's still a more efficient because the 10 split unit probably can do the 3 floor. So in terms of the cost, the split unit, the central unit then costs more to install one, right? So the
Than
installation
install
cost
10 split
is
unit.
more. Huh?
Than to install 10 split unit.
Yeah, man,
George,
split unit not
George,
difficult, not expensive
Uh,
to install.
George, let me tell you something. People just don't get up and just spend money and say, okay, my fee for a central unit, not just shopping at central unit. We just use a 10
Central unit
minutes.
costs a lot of money, man.
Yeah, maybe use 10 minute split unit. I mean, they're going to look at it from an engineering standpoint and then work out the pros and cons and say which is the best option for us based
Yeah.
on the type of operation we are going to conduct in this inside of this building. So the one that works well for them, they just go along with that. However, sometimes when people embark on a particular system, AC system for the building, after 10 days on the operation of the building, they say, okay, you know what? Might as well we just install some mini split unit, right? Because we recognize that there are times. For example, the government asks um, um, government workers, those non-essential, I mean, those who work at tax office and elsewhere, not to come into work from home. Then what about the essential ones? It may be just 10 of them as opposed to let's say 100 of them work in a building. 10 of them come there.
Still have to
The
turn
whole
off
entire I think I turn on just a cool one entire building. When you could just for that particular year just turn on the unit, the split unit for that, just to cool that area and the person who in the other section, rather than the turn on the whole. I mean, what you call it, the central unit to cool the whole entire building. They're wasting a lot of money there.
Yeah. No, what they do now, George, is actually have a combination of the two. So, for
Yes.
instance, I have some small offices where the managers and so forth, right? Most of the time, the
Okay.
managers would have to come in on weekend. Agree? To do some
Okay.
managerial function. What they do is actually use a combination of central unit to cool the central area where persons,
When
customers
you have full
are.
staff compared to
Yes.
when you have
And then
small. Okay.
them
Okay.
have the central, and then them have the small split unit serving the offices. Right? So when
Okay.
you come in at a big area, central unit, but when even the supermarkets do it nowadays, so rather than carrying duct now, most of them will do them refurbish, them just duct to the general area where the food is with the central unit, and in the office spaces where you have the account staff, the managers and so forth, they use split unit. All right, so this is how we use they use a combination of the two type of units to actually um, make the system more efficient.
Yeah, because at the end of the day, they are going to
Okay.
look at what is cost effective,
Yeah,
right? What is energy efficient, right? And then if they at the end of the day they decide, okay, let's just incorporate both of them. That at the end of the day, we decide what to turn on as opposed to what to turn off. Or if it's just one of them they need, which one they are going to go along with. But at the end of the day, it must boil down to energy efficient, cost effective, etc., etc.
yeah. And that is why God just jumping back in terms of efficiency back to electrical system. When we talk about large spaces, right, this is why we switch the lights in section because sometimes not all the sections are being utilized at the same time, right? So this is really and all of this come down to what you propose to them as the engineer on the job or the design engineer, right, or the design electrician on the job that is say, listen, based on your function of your building, it's better to switch in 4 sets than in 3 sets because you can switch that section here when and all of this come from when you are talking with the customers, into the to determine their design requirements, right? Because that's a critical part of any system as an engineer, right? You have to talk to your customer, get the customer's perspective. A lot of time they don't really know what they want, but by them talking and explaining, you as an engineer know, when you say, all right, based on what they say, you make your jottings, you go to the drawing board, you do your calculation and say, listen, you need a central unit of this size. You're going to use the central unit to cool out of the area here. Now, this area in the offices, now you're going to buy some inverter type units, right, rather than use a central unit to cool everything, right, where we can save some energy here. Because sometimes the manager can come out and be on the shop floor, right? So the AC I go run at the compressor will run at a slower speed, save energy, right? When most of the time, sometimes, as the operator say, might have 3 managers or supervisors sharing a space, right? So this is what persons do to actually save energy, save money, right? Because instead of having 3 rooms where you have to go put 3 units, you put them in a room, you use a split unit, right? Everybody have them like a cubicle or space in the room, right? And so forth. So as they design engineers, they will mainly the architect when they're doing in initial design, and this is why most of these consulting firms they have a electrical engineer on board, the architect on board, the mechanical persons on board, because developing a complete plan, building plan, or facilities plan will incorporate all of the different disciplines. All right, so the architect of the talk, when they are, if you talk to a lot of these architects, right, when they are studying, they do electrical, but they the amount of electrical they do, they are not able to completely design the electrical system, right? They learn the symbol them and they know say boy the room you have to have a switch, the room here probably have to have a light and so forth and so forth. But this is where the electrical engineer will come in, where they say, all right, based on the area, give me a second, based on the area.
Um, you know, one typical example is like the hotel industry. Um, the tourists them, as whenever they're inside the room and have to leave the room, they leave the television on, all the lights in the room on, and the AC unit to be running at the same time. And then sometimes it's hours before they come back in their room. Now, if that happens in every room, which used to be, that's a lot of energy that hotel is burning, and they would have to pay JPS a whole lot of millions of dollars, even though we know that they are making a lot of money so they can pay their bill. But I mean, they devise a way now to cut back on the energy that they use in the hotel industry. So after somebody leaves the room, within few minutes, the TV bomb lock off. They put in all the mechanism, the technology in place. That after few minutes, once there's no movement, the TV lock off, all the lights turn off, the AC turn off. So it's when you get back into the room, you actually have to turn on all of those things. Well, if there is a small, normally some of those hotels them have some little small refrigerator in there with things packed in there for you to drink, like beer and all of that, soft drinks. But that would be the only thing would be on. So I mean, these are the kind of technologies that they are trying to, not trying to, that they are using to cut back on the uses of energy by the tourists. So I mean, this is what people are now doing to save a lot of money, and the hotel industry, by virtue of using that kind of technology, I mean, they are saving a lot of money. I've been to the office of the Prime Minister. I've been to different places there, and as somebody steps out of that their little office, perhaps for 2 or 3 minutes, if there's no movement, I think this type of switch that is installed at the door, like it has a motion detector on it. Once there's no movement, the lights in the office turn off. So I mean, even office spaces in government um, facilities, government agencies, they are using them. That once there's no movement in there for a while, it just turns off all the light, and they're saving a lot of money. And it's the same thing with the AC units.
Yeah, all right. But we had a couple of years ago, we had invested in a lot of motion detectors at UTech, but I don't know, so the vandalism of these devices happened, and because of the cost at the time, because the technology was actually new at the time when we installed them, because I'm talking about probably when I was doing the diploma, right? When we went into a room, the lights will come on, right, based on the occupancy, right? But then persons vandalize them or whenever replace them. But I think now that we are moving in to an era now where we're talking about a lot of savings, then we need to start to revisit these devices, right? Because when technology is new, as we know as engineers, the cost will be high, and as the technology becomes more readily available, then the cost gets less, right? Not to say it gets cheap, but it gets less. And the same thing with every technology. When we had a rollout of the inverter ACs, the costs were a bit more expensive than how they are now, right? So with the improvement of inverter ACs or inverter HVAC system, fridges, and so forth, then the cost of these devices or equipment become less, right, compared to one time. All right.
You notice that they're using them all in the bathroom too, on the bathroom pipes. It's particularly
Yeah,
in banks and those places. So you don't have to turn on any pipe. You just put your hand underneath it.
and
There's
the
a sensor
sensor,
that senses that your hand is there. Turn on a valve, you wash your hands, you move, it just shut off. I mean,
right?
so
So
everything is just energy efficient.
yeah, all of this is driven by engineering, right? All of this is driven by technology and IoT, I should say, guys. Internet of Things, right? And is actually taking over. Another 2 years, boy, we'll probably be amazed of what is available. I
But I
will.
don't know how the medical doctor and the lawyers, the accountant, the banker, why they get more rating than the engineer. We just can't make sense of it. And
Because we
engineers, how who make the world go round and round. I don't know. Everything that they use, right, in the banking industry, in the medical industry, by the lawyers, I mean, every strata of society. All
yes,
right.
but
Engineers. And I don't know why we don't get that kind of rating that the medical doctor and
because
the bankers, I don't know.
Mr. Predator, we sell short, right? And if you talk to a lot of engineers, if you do a lot of research, they'll tell you that we originally, when our discipline was flourishing, we sell ourselves short and we make the business people market for us. And then, so the person who actually do the work is not praised as a person who put the thing on the market, because a lot of these companies, the engineer behind the scene, the owners of the company not even know anything about engineering, right? So that is also how the society is now. It can be changed, but it can take a lot to change it. All right, so moving along, we talk about control, right? We talk about direct digital control or DDC, right? Is the automated control of one or more devices, right? So these use output signal generated from a computer, right, to control the system. So when we talk about whole system control and whole building design, right, we talk about computer-based control systems, right? Now, in terms of the technology, if you can realize here, it has been in use since 1970s, right? So it's nothing new. It's just that because of the improvement of semiconductor devices, then it's more widely used now, right? So the use of the investment in semiconductor devices make them become more stable, and the more stable that these devices are, then the more the electronics is incorporated in our everyday use, right? So it's not anything new, these controls, but as we move along, our technology increases, we learn more, right? And then we function better. Well, we should function better in our daily lives, right? Now, DDC is used in all new installations. That's direct digital control and can be installed in existing buildings where mechanical or pneumatic systems are in place, right? So this is where your MATLAB programming come into place and all of these sensors and things to adapt the older type system to the new digital control. But again, it's better you just buy a new system, right? Because you might talk about the age of the devices that you have in the old system, right? And then, as we know, as engineers, as things go on, then the lifespan of the thing depletes, and then after a time it will stop work, right? These systems, as we say, can be retrofitted and upgraded to support these type of control, right? We start with a controller, a device that processes input signal, which we all know, right, for persons who digital signal processing, and calculates the output signal necessary to control the internal environment, right, using the building equipment. So a lot of time, when you go in these new modernized building, what you will see is a building management control console, right, in a control room where they can actually do everything. They can monitor all the different locations, control all the different atmospheric conditions that they want to control from one central location, right? And this is becoming more and more adaptable in our modernized buildings, right? So we're talking about our control room. Is not, we don't talk about the so our power systems alone now and all of this. We have to talk about control room in almost every type of situation now, whether you talk being a supermarket situation, right? Because these supermarkets tend to start to get larger way of different areas. You have eating areas, all different type of areas, right? And all of these areas have to be monitored or are being monitored from a central location, right? So as technology improves, this will you'll see this more and more. Now, with the integration of IoT, our managers now are able to just go on their devices, whether it be a cell phone or a tablet, and is able to view and monitor the system performance, right? And you can probably optimize it. So what a lot of these systems are now, we have an optimization graph that once your building output is matching that graph to certain percentage of error, then we're saying that our building performance is optimal, right? And that is what we are striving to achieve now when we talk about our ISO standards as it relates to building management and air quality control, right? So for persons who don't know, it's the International Standard Organization, the ISO, right? And this organization really have some standards that a lot of countries in the world is adopting now in terms of their building maintenance, the air quality inside the building, the comfort level. When we go to lighting, we talk about the usage of daylight lighting. So when we're going to talk about that when we reach lighting, or I'm going to point you to where you can go, right? So when one of your individual assignment is really you going to a site and you're going to do a webinar series, and then you are going to answer some questions and they're going to issue a little certificate to say that you have gone through the webinar. Your individual assignment is going to be for you to upload the certificate to the and the grade that you receive, right? So that's going to be one of your individual assignment to be done. All right. So this is really more type control, and I tell you about, remember we talk about the control loop, the continuous control loop, because we always have to get feedback. When we talk about the more optimized systems, we'll have a better type of control, right? And the best type of control is to have a continuous feedback, because then you need to continuously adjust your outputs for optimization of the system. So for the system to operate optimally, you have to have your continuous feedback. And this continuous feedback is done from your sensors. The sensor is going to pick up the air quality, you're going to pick up the noise level, you're going to pick up the temperature, and you can pick up the moisture in the atmosphere. All of this is sent back to the system so that it can be at its desired set point, right? So you do controls, you know about set point and all that, right? And this is actually how these type of control now. As it relates to your interface now is where we talk about our MATLAB. MATLAB is being utilized a lot now when we're talking about automation, right? So their integration of their DAQ modules, their DAC modules, are making it much more simpler for you to collect data from systems, right, and encode it and transmit it to your central processing unit, right? So this is basically, again, utilizing the technology, utilizing what is there, using what is there to improve our social standing, the benefits that we can retrieve from these engineering devices, right? And again, as Mr. Freitas said, persons don't really appreciate engineers because we don't market the device. Because the first thing, you know, we design a device, right? And we get a marketer, we get somebody, and then they're going to say, listen, you can make X from it. They might tell us they might give you this. And then when they market it, it's all like enough to you, you know. But guess what? When them start market your device, their money, they might tell us they might go put this for advertise, them have to put that for this and all sort of thing, right? So because they don't train us to be marketers, you have people who go to school to do that. They train us to solve problems, and that's basically what we are doing, right? Solving problems. All right. The benefits of using control, you know them already, but just to put them in context, automation and efficiency without having to manually adjust settings daily to control a building environment. So basically, we're talking about the automation control improves our efficiency. So every day we now have to go there and turn on the system. For instance, when you set up your building management system, we know that in room one, right, the temperature, because nowadays, even though our split units, we can tie them in back to our central thing based on control, direct logic control, right? We can tie in all of these split units to a central unit that will send out computer that is controlled with the computers. So we know say room one should be at a particular temperature when the AC come on, right? So before you get to work in the day, at 7 o'clock, the unit going to come on, start cool down the room. By the time you reach, the room cool, right? So when you reach to work, you don't have to turn it on. No, they can actually set it to that, as Mrs. Freitas said, that you have our motion detectors that it will turn on these devices when you enter the building. So your light will come on. You have even devices now that will adjust the intensity of the light, whether you want it to be dull, whether you want it to be brighter, and so forth, right? Our inverter AC will adjust based on the occupancy. So if you have 3 persons in a conference room or do a conference, then it will it will vary the compressor speed to match the temperature that you want or the set temperature, right? These type of control basically provide protection of building and contents by real-time monitoring, as I tell you before, such as the heating system, the cooling system, the humidity, and so forth. It reduces operating costs, right? By monitoring performance and optimal equipment runtime. So based on the preference of this person, it is the optimal time to turn on the AC because you realize that this person consistently reach work at 7:30, right? So we might say we can turn on the AC at 7:25 or 7:20. So by the time the person come into the room is cool, right? So we use all of this to feed all of this data into the system, and it will, in essence, contribute to our overall operating costs. Again, it can be a combination, as I say, of different types of system to optimize a system. So optimizing a system does not mean you use one particular solution, right? As the engineer, you possibly need to use a combination of solutions, right? So your central area, you have a central unit, and for the small offices, you have a split units, right? And so forth. And these split units, as I say, it's very difficult now to get a regular split unit. So most likely it's going to be inverter. Couple years ago, the Bennett going probably be another type of thing, right? Now, increased comfort. We said the benefit of using all of this digital control and digitization age and the Internet of Things is for the comfort and productivity, right? So the more comfortable some workers are, is the more productivity you'll get out of them. Like me sitting here now, right? I'm hot. Meanwhile, if maybe probably had won this class from my office, I will be in a much cooler position then. But when we go to the office, probably me alone when be in the office and I've got to turn on a big central unit to cool down just my office alone, right? To get cool. So that's a drawback, right? So we don't have any split unit. I will have to turn on a big. I will have one person in the office. We have to turn on a big central unit, right? So that's a drawback again. So everything you look at right now, in terms of control, guys, I want to say this to you that when we're talking about building management control, it will incorporate the fire system, the sprinkler system, right, for in cases of fire. It's going to incorporate the lighting system, it's going to incorporate the AC system. All of this can be in one command center, right, being monitored by probably one or two persons. That is where the technology is going. That is where that is what controls do to productivity, right? It increases productivity. The drawback is that it rather than have 5 people, now you only need 1 person, right? So you need 1 operating personnel compared to 5, right? As 1 person can then monitor the screens. No, when everything is going right, you know, everything good and fine. But then there is a drawback to having just 1 person, because when something goes wrong, that 1 person have to find that something that is going wrong and try to fix it, right? In a lot of cases, what companies tend to start to do now is have maintenance personnel and repair personnel on contract, so that they, when we reach maintenance part, we're going to look at these aspects where they have them on contract, right, on retainer. Some of them have them on retainer, so the retainer cost is not high, right? But then when they send out a request, then the company will send a team to the location to activate the necessary repair or maintenance. All right, so that's one way to optimize performance and operating costs of these systems. Even your AC system as well, because most companies, rather than to have in-house AC personnel, then they have a service contract with a company, service/repair contract. So in case of servicing, they'll come in and they'll service all the AC units for probably a 1-week period, depending on the amount of units, and they'll effect repair on any unit that needs repair, right? So these are how companies are optimizing operational costs, right? So even though they have their monitoring centers, they'll still have their service contracting place, right? So reviewing the system, we said basically a HVAC system of several requirements, including primary equipment, right? These primary equipment involve heating equipment, cooling equipment, and delivery equipment. Your space requirements, such as HVAC facilities, you're going to need to determine if you're going to have a central unit or a split unit. The equipment room, whether you're going to have a central processing room or a central command room or control room, right? Whether you have a vertical or air distribution system, such as a ducting system, or you have a split unit type system, right? The type of HVAC system can be divided into 2 types. So we have the central system type, and we have the local HVAC system type, right? And again, the central system type can serve multiple or single zones and are located away from the building, right? And the local type is mostly placed inside or adjacent to the living space or building, right? And typically most of the time serve 1 zone. All right. Controls are the foundation. We know that. We just discussed that. With no control scheme in place, you typically have thermostats that read temperature and heat or cool a space based on that reading. And that is why the inverter type AC becomes more in demand compared to that of the previous type, right? Because with the inverter type, you don't need much building management. You can just leave it alone and it will manage your efficiency and the cost of operating the unit, right? It's either on or off. This means wasted energy, limited control, and reacting to problems instead of proactive maintaining equipment, right? And that takes us to the end of today's lesson. All right, so we get a full overview of what the HVAC system is, right? We understand the need for efficiencies in this system, right? We understand the need for improved technology and monitoring within these systems, because it does improve our system, right? And if you need to do some little bit more reading, so you need to do some more, right? But I try to cover it as much as I can, right? And again, guys, hopefully I'll be able to send your test score soon, right? And again, continue reading from now because you have your unit test after this, after unit 4, right, which is going to cover unit 3 and unit 4, right? So you need to continue reading because it's going to be an online multiple choice test, right? I don't think I'm going to put any short answers this time because the short answer kind of take time because of the number of you guys, right? So it's about 50 something of you guys, you know, so a whole heap of reading. Imagine when I'm ready to do the final exam. Anyway, with the final exam, I would have wrap up modules, so I'll have more time for marking. All right, so have a nice day, guys. I'm going to leave you now. Keep safe. All right. COVID is there. Boy, amount of person I know. First, last week I was saying to my wife that them say we have the fastest infection rate. Oh, me don't know no person will have it. You see, by the time I said that, by yesterday, me heard that person have it, that person actually no. So I was saying that the report probably be false because if they are saying that our infection rate is this high, how me don't know no person, but by yesterday, I realized, boy, I know about 10 person personally, I know. And say them have COVID and them COVID positive. One guy saying go to the hospital, then turn him back. Him go chest hospital, then turn him back. So it's getting serious, guys. So what I'm trying to say
the news last night, sir?
Huh?
You saw the news last night with the mother that took her daughter to UA, to UC.
Yeah.
Because she had an asthma attack and they would never appear in a man until the child died.
Listen,
So,
that never get me worried, you know, because my big son have asthma, you know, so and my auntie tell me about a case that she went to the hospital and well, she went to the doctor and the person started to have an asthma attack and not even the doctor didn't want to attend to the person. And she have to go and take the asthma pump and pump the person, right, for the person recover enough. They don't want to. So if doctor afraid and I stand up, what you expect me to do? Me don't want afraid, right? So just keep safe, guys. Continue to observe your personal protocols, sanitize, stay away from persons if you can, social distance as best you can, right? And we'll try to see if we can make it through this pandemic, all right? So,
cool.
yeah.
If healthy.
Yes, that's true.
Stay healthy.
Yeah, that's true, Mr. Freight. All right, so take care, guys. Next week, we will move on to our next unit. All right?
All right, sir.
Come on, cool.